In this short video, we are going to analyze a monopolistically competitive market. Let's suppose that Woolly Bully is one of many firms in the monopolistically competitive market for hand-knitted mittens. The inverse demand for their mittens is given by P equals 6D minus 5Q, where Q is pairs of mittens and P is the price per pair. We're also told that Woolly Bully has a total cost of 10Q plus 125. We are going to do two things. First, we are going to determine Woolly Bully's profit maximizing quantity and price. Then we're going to determine if the mitten market is in long-run equilibrium. So what do we need to know to answer this question? We need to know the inverse demand for the firm's product as well as information about their total cost or marginal cost. How do we solve this question? It turns out it looks just like solving a monopoly question, which makes sense because in a monopolistically competitive market, each firm does have some market power, so they behave as a monopolist would. What does that mean? That means they're going to set marginal cost equal to marginal revenue to find their profit maximizing output, and they're going to look to the demand curve to determine what price they need to charge. So let's solve this question. Here's what we know. We have our inverse demand and our total cost curve. And the first thing we're going to find is the profit maximizing quantity and price. To do so, we first need to determine the marginal cost curve as well as the total and marginal revenue curves. So let's start with marginal cost. Marginal cost is always the derivative of total cost with respect to Q, which in this case, if we take a look at that total cost function, we see that that derivative is just going to be 10. So this firm has a constant marginal cost, which is going to make the math very simple in this example. We also need to find total and marginal revenue. As a reminder, total revenue is inverse demand times quantity. So in this case, we take our inverse demand curve, 60 minus 5Q. We multiply the whole thing through by Q. So we get that total revenue is equal to 60Q minus 5Q squared. From that, we can find our marginal revenue. It's the derivative of total revenue with respect to Q. So that derivative is 60 minus, bring down the 2 from the Q squared, multiply it by the 5, so minus 10Q. So we have the two functions we need to find the profit maximizing output. Our next step is to set marginal cost equal to marginal revenue and solve for Q. That will be our profit maximizing output. So we have 10, which is the marginal cost, equals 60 minus 10Q, which is our marginal revenue. We want to solve for Q, so I'm going to rearrange a little bit. I have 10Q is equal to 60 minus 10, which is 50. Now I divide both sides by 10. And I get that Q star, the profit maximizing quantity, is equal to 5. Now that we know our profit maximizing quantity is 5, we just need to substitute that into our inverse demand curve to find price. So in this case, price is going to be equal to 60 minus 5 times 5. 60 minus 25 is $35. So we can call this P star because it's the profit maximizing price. So our final solution is the firm should produce 5 units and sell each unit at a price of $35. We have one last question that we're going to answer. We want to know, is the mitten market currently in long-run equilibrium? Here's all the information that we have and that we have solved for. We have our marginal cost, our total revenue, our marginal revenue, as well as the profit maximizing quantity and price. How do we approach this question? Well, we have to remind ourselves what's going on in the long-run equilibrium. If we're in equilibrium, then profit should be 0. So how do we answer this question? We are going to compute profit at this profit maximizing price and quantity, and we're going to identify whether it is positive, negative, or 0. What is the baseline formula for profit? It's equal to price times quantity minus total cost, which is a function of quantity. So we just need to substitute in what we know. Price is 35 times quantity of 5 minus our total cost. I'm going to put a bracket because my total cost function has 2 parts. So I have 10 times quantity, which is 5, plus 125. Doing a little bit of math, it turns out that 35 times 5 is 175. And in here in my brackets, I have 125 plus 50, which is also 175. 175 minus 175 is equal to $0. So the answer to this question, is the mitten market currently in long-run equilibrium, is yes. And I know it's yes because this firm is earning zero profit.